Hello everybody, this is Dan again. So far we've learned about the technology powering the OptoNano and how it works. But now I'd like to show you the real thing, a behind-the-scenes peek of what's inside and show you an actual demonstration. So what I have here is a typical OptoNano setup. The OptoNano microscope is here, but there are a few more supporting items. So please give me a moment to go over each of them. First, to create a quiet work environment, we have a vibration-damped optical workstation, sometimes known as a breadboard, and a desktop work surface with active electronic vibration isolation. Here we have the OptoNano software, running on a mini workstation computer with 3 GHz, Core i7 processor, and 16 GB of RAM. The monitor is a 26-inch 4K high-resolution monitor. This type of computer is needed for the image processing and stitching function that I'll show you in a bit. This 4K monitor is recommended for the best viewing of the images. We really want to see the power of the OptoNano. What's also here but not visible on the table is the motor controller. We've removed it from the work surface to eliminate it as a source of vibration. In this case, it's mounted under the table. Now the controller runs the 3 axes of the XYZ linear positioning stage used to position the sample, in addition to a single axis vertical translation stage to autofocus the image. The motor stages also work with the image software to enable OptoNano's image stitching function. Now back to the OptoNano microscope itself. From the outside you can see that the design is both compact and sturdy. The OptoNano has a protective case surrounding the inner workings, so to get a closer look, we have to pull the cover off. And by just removing a few screws, we'll do the trick. So we lift up the cover vertically and carefully to see what's inside. Now you can see the major components of the OptoNano, from top to bottom. There's the USB 3 CMOS camera with a 5 megapixel detector, and off to the side, the coaxial LED. You can see the main body of the OptoNano, which combines the camera with the optical path and the illumination path. Below that, we have the 4-position manual lens turret. At the moment, it's holding a standard objective and the special OptoNano Microsphere objective. Finally is the XYZ motorized positioning stages for holding and locating the samples. These motor stages enable sample focusing and the image stitching function that we'll show you later. Also integrated into the sample stage is an optional flat LED light for back illumination. This is the activated backlight showing on the sample stage. Here's the Air Force resolution test target we'll be using for the software demonstration. It clips in here on the sample stage. So, now that we've had a peek to see what's inside the OptoNano, I'll put the cover back on and run the system software to show you how it works. Okay, here we go. So we'll begin the demonstration using a 10x objective lens by looking at a pre-focused image of the resolution target, the target we showed you earlier. Now let's switch over to the Microsphere-enabled super resolution OptoNano lens. And in this demonstration, I am manually focusing the objective to the sample using both the Z focus arrow buttons up and down, but also the left and right translation stage to really find the area that I'm looking for. Okay, now this red box defines region 11 on the target where we want to focus for this demonstration. So I'm going to move back over and find that region and then focus in. Okay, that looks pretty good. Moving over, get it centered really to that region that I want to look at. Okay, so now let's perform the auto-stitching function. The main benefit for using this feature is to construct a larger overall image while maintaining the super resolution. Okay. Now for the OptoNano stitching, let's define the microsphere area. We've done that, which is the center of the sphere. That's what I've done with the blue box. Next, you want to define the area that you want to stitch together for observation. That's defined by the red box. And then we're ready to go. So the number of rows and columns to stitch in order to cover the area selected are shown on the bottom left corner of the screen. And in this case, we see 3 rows and 2 columns. The status of the stitching process is also shown within the status bar. Now you've probably already noticed that during this process, the lens will zoom in and out from the target. And really this is to prevent the sphere from crashing or coming in contact with uneven features on the sample. All right. And we're almost done here. Now the image on the right shows the result of the 6 images that have been stitched together. And the contrast of the finished image can be adjusted by scrolling this bar up and down. You can zoom in and out from the stitched image and also perform measurements, which I'll show you next. First, let's get to that area that we want to look at, which is the 11-5 in this case. And we'll snap some dimensions. Now what I've done in this case is I'm looking at the line width. I'm showing 161 nanometers of spatial resolution within the 11-5 area of the target. So now you've seen the actual product, as well as a behind-the-scenes peek of what's inside. The software demonstration clearly shows how the image capture on the OptoNano works. From here, let's take a look at an actual use case.